Hello and welcome. Over the next few minutes, we're going to explore the Robot Doctor initiative. The Robot Doctor is an 8-episode PBS TV broadcast and web streaming series that reinforces key math concepts and inspires through robotics. There are supplemental materials and educator supports to help integrate materials into lesson plans. These class-ready, low-tech and no-tech resources are available to educators across Pennsylvania today and throughout the school year. Introducing and supporting this initiative are Dr. Maxim Lekachev, founder of RobotWits and a member of the Robotics Institute faculty at Carnegie Mellon University. The Robot Doctor is Jonathan Butsky from RobotWits, Tim Heffernan, founder of PA Rural Robotics Initiative, and myself, Rachel Burcin from RobotWits and Carnegie Mellon University. We would like to thank the partners, supporters, and sponsor for making the creation of this unique resource possible. The Robot Doctor collaboration comprises media, industry, education, and government partners. Production was led by WQED. RobotWits led the math and robotics content and shared creative design with WQED. PA Rural served the critical link for educators. We are especially thankful for supporters for their guidance throughout. This project and initiative aims to do 3 things. First, reinforce math concepts by drawing upon and sharing examples that are inspiring from robotics. 2, increase STEM career awareness and real-world relevancy of math, and encouraging students to build a strong foundation in math to serve them in future careers. We're also working to expand access to STEM careers for all communities, especially underserved communities that may also be underrepresented in STEM by addressing perceived and real barriers to STEM careers. The series is accessible with or without the internet. No internet is required. Materials have been created in a no-tech and low-tech format to be accessible in the classroom while learning from home or online and for most out-of-school environments. You can stream, download, or watch on TV. The resources are available on multiple websites: WQED, RobotWits, and PA Rural Robotics. The series has also been broadcast across Pennsylvania on all of the 7 regional PBS stations. The series creates special supports and unique resources that connect to students to real-world examples of math through robotics. The goal of the project, an additional goal, is to, through collaborative efforts, to empower teachers to bring world-class resources for them to use in the classroom with their students. Throughout the broadcast, educators could receive assistance in customizing the content for their classroom. Many of these supports were unique in nature. This is the first time that robotics experts were available as teaching assistants for your classroom to help you customize materials from the Robot Doctor or to ask questions about robotics. There have been online weekly meetings, and there will be professional learning opportunities. At the websites for WQED, RobotWits, and PA Rural are resources and assignments that are no-tech and downloadable for you.
As Rachel said, through this initiative, we would like to motivate and reinforce math concepts and also lower the barriers that high school students often perceive in pursuing STEM careers. Through the next few slides, I want to give you a sense of the series, and I think nothing is better than just showing a few snippets from them. The host of the series is John Butsky. He has a PhD in robotics from CMU and extensive experience in building all kinds of different robotic systems. Every episode is exactly 14 minutes and starts with the following.
Hello, my name is Dr. Jonathan Butsky. I'm not a medical doctor. Instead, I'm a robot doctor.
You get a sense that each episode will have lots of examples from robotics. The snippets I'm showing in this specific slides are from the episodes on how robots measure things. It covers all kinds of different measurements that the robots have to do. It was actually given us as a topic that one of the high school math teachers wanted to see, as she felt it was not covered enough in high school.
Robot needs to be able to measure things, distances, size, angles, time, and other things. We'll explore all that in this lesson. You'll need to rely on the math you already know, geometry, trigonometry, algebra, and some concepts from physics. But be prepared to take notes. For the next 13 minutes, we'll discuss how robots measure. We'll look at how robots determine distances, how they measure angles, and how they measure time.
The math concepts that are in each episode range from very simple ones to substantially more complex ones. So for example, in this specific snippet, you'll see how we use robotics to motivate the use of nano, 10 to the power of 9, when explaining what are the different scales at which one can measure different things.
And believe it or not, there are nanorobots. They're named because they are very, very small. These robots are used in medicine, where they're injected into your veins, travel through your body to your heart. They can monitor, clean, or fix damaged portions.
So that obviously was a pretty simple material. Now, of course, there are more complex, and this specific example that you'll see in a second is a more complex concept that involves formula for speed. Mm-hmm. Simple or complex concept it is, the common thread though is always to motivate its use in robotics.
Another place that speeds show up is when a robot is trying to figure out how far away an object is. A common sensor for measuring this is the LiDAR. The LiDAR is like a radar, except for it uses infrared light instead of radio waves. LiDAR works by transmitting a pulse of light. Light in air travels 3 times 10 to the 8th meters per second. In other words, it travels 300 million meters every second, or 300,000 kilometers per second, which is the same as 186,000 miles per second. The sensor times how long it takes the light to travel out to an object, then bounce off and return back to the sensor. Since light travels very fast, the time for this trip is very short. In fact, it is usually measured in nanoseconds, billionths of a second. There are 1 billion nanoseconds in a second, or 1 times 10 to the negative 9th seconds per nanosecond. Let's look at an example. Our robot is sitting outside looking at an obstacle. It uses its LiDAR to get a range to a nearby obstacle, in this case a tree. It gets a reflection back from the tree after 30 nanoseconds. That's our measurement of time. But how far away is the tree? We know that speed is equal to the distance divided by the time. We can rearrange this equation to show that distance is equal to speed multiplied by time. Since we know the speed of light is 3 times 10 to the 8th meters per second in air, and we were told that the time was 30 nanoseconds, we can multiply these two terms to get our distance. A nanosecond is 1 times 10 to the negative 9th power. And we can rearrange to get our units all together and cancel out the seconds, then multiply the numbers and simplify to get our total distance of 9 meters.
Now, as Rachel said, our goal here is not only to provide this material to students, but also to empower educators with these kind of powerful motivation examples that they can use in teaching math, and also to be able to do it in an online fashion. So to this end, each episode comes with a take-home problem that we call challenge question or set of challenge questions, and teachers can decide on whether to grade them or not, to discuss them in class or via their online sessions or not. However, it is a resource that is out there, and here's an example of that.
This week's challenge questions are, if we had a robot with a sonar sensor, how long would it take us to get the return pulse or echo from an object? We know the object is 10 meters away, and we know that the speed of sound in air is 343 meters per second. Again, if we know an object is 10 meters away, and the speed of sound is 343 meters per second, how long will it take to get the return echo?
Altogether, there are 8 episodes covering a number of different topics in robotics, such as how does a robot measure things. This is the example that I just used in the slides that you saw before. How does a robot know its position in the world? How does a robot sense things around it? How does a robot sees other objects? How does a robot move? How does a robot follow a line or a simple curve? Each episode maps onto several math concepts that are being used. So for examples, equations of circles, trigonometric functions, Pythagorean theorem, ratios and proportional relationships, vector quantities, equations and inequalities, rules of probability, and many more topics.
Hello, everyone. I'm Tim Heffernan, the Education Liaison for the Robot Doctor. I want to thank you for taking the time today to hear about the tool that we've created for you to add to your toolbox going into the fall and beyond. I'm going to do my best to cover this all in 2 minutes, so I'll preface everything with my contact information is at the bottom of the screen. I would love to take time to share more information with anyone that's interested in talking about anything from our presentation today. And in particular, I'd really like to hear suggestions and comments on how you feel like it could be beneficial and maybe improvements that we made to help you in your classroom. I'm going to give the K-12 perspective here as a teacher that's been in 20 some years a social studies teacher turned gifted support teacher, ending up as a STEM teacher in my school district. I'm also the founder of the Pennsylvania Rural Robotics Initiative. We have 25 districts in Northwest Pennsylvania that engage in our programming. So I'm looking at the Robot Doctor through a lot of lenses. And again, I'm going to give you the mile-high view of how I see it can help you. First, who can be using the Robot Doctor? The 4 key things that come to my mind are my math teachers, my gifted education teachers, our STEM educators, robotics coaches, and you know, I should probably throw our physics teachers in there too. There are different levels that I think this content can be used. One, in our math teachers, we know it can definitely support and add additional resources to lessons that are already being taught and focus on content that we need to make sure that we're covering and reinforcing. I also think that the Robot Doctor makes a really valuable tool for making connections from all of the different subject areas that are relevant to it in real life application. I think showing kids those connections is something that's super valuable. As a gifted support teacher, I know for sure, both through enrichment and acceleration in a classroom where I used to focus on project-based learning, this would have been a great resource in that classroom and out with my regular education teachers. And I guess the last point I'd like to make is as a robotics coach who was once a social studies teacher, and knowing that a lot of my other coaches are librarians and English teachers, I see the Robot Doctor as being a resource that lets us bring that additional rigor and really some relevance to some additional teaching that maybe we aren't equipped to bring, and not maybe we're not equipped, that we know we're not equipped to bring to the level that we're going to get, whether it's through Dr. Butsky and Robot Doctor or any other type of world-class content like we're creating here. So I guess my next point that I need to jump into is, how do you use this content in your classroom? Weekly, there'll be the lesson discussion questions that will come out prior to the next week. You'll be able, as an educator, be able to see, and now that it's all created, you can see it in advance, but I guess as we were working through, you could tell what was coming the next week and see how to make those connections within your classroom and your lecture. And then moving into the next week's discussion, you have contact with the RobotWits TAs through email. As you view the next week's lesson and begin to take that out to your students, you have those resources to fall back on, the emails. But there's also another piece that I'm particularly happy about, and I think we're going to see more of this as we go forward, is supports for teachers, is the weekly Zoom. that weekly Zoom would let a teacher get online and talk to Dr. Butsky about last week and to help prep for next week as well. So I think that resource really really tightens up and maybe it takes away some of the fear and reluctance, both from distance learning and from when we're getting into some STEM concepts that are you know, in my case, maybe a little bit over my head. And without getting, or maybe something that I haven't looked at in 15 years, and I need that opportunity to go back and connect with somebody to get me where I need to be comfortable with my students. So again, thank you very much for the time today. Our goal was to create something that was accessible and equitable, and something we could get into our kids' hands through COVID. But we know it's going to be a powerful tool going forward. And again, I'd love to hear any thoughts or comments. Thanks so much.
Thank you for spending time with us today to learn about the Robot Doctor Initiative. 8 episodes available to you now and support throughout the year. The episodes you can stream, download, or watch on TV. We hope that you will reach out to connect with us, that we can learn together and grow as a community. There's going to be a lot of challenges for all of us over the next coming year. So these materials are ready to support you in teaching in whatever environment may come. We'd love to hear from you. Please reach out and email us at rachel@robowits.com. Thank you.